So we're given a position function in this problem, and we're asked to use limits to determine the instantaneous velocity of the projectile that follows this path at t equals 2 seconds. So in short, to do this, we need to find the instantaneous rate of change of the given position function. Now there are actually two ways to do this. We could use the limit definition of a derivative, which looks like this. And this instantaneous rate of change of the position would give us our instantaneous velocity of the given function. And then what we would need to do is plug into that t equals 2. That's a totally legitimate way to do this problem. But there's another way to do it. Because we're given a value a equals 2 where we want to find the instantaneous velocity, we can use this limit definition, which looks a little bit simpler. And I believe this is the formula that this section of the book wants us to use. So we'll kick this one out, and we're just going to use this formula right here. Now plugging in a equals 2 gives us this formula, and we can plug the given function s of t into this formula. And we need to find s of 2, so maybe off to the side somewhere. S of 2 is the value that we get when we plug t equals 2 into that given function. I'm getting that that number is 40, so we can plug that in right here. And I'll leave the denominator as it is, t minus 2. Now, if we try to plug t equals 2 into this expression here to find our limit, we're going to get an indeterminate form of 0 over 0. So our only choice is to do some algebra so that we can cancel this t minus 2 out of the denominator. That's going to mean factoring the numerator. The first thing that I'm going to do is factor a negative 4 out of every single term in the numerator, and I'm going to pull that out in front of our limit. Now, we have this trinomial. It has 3 terms, and we need to use all of our factoring skills to factor it. This happens to be a trinomial that has an a value or a leading coefficient that is not 1. That makes it a much more difficult trinomial to factor. You can factor it by guessing and checking, or you can use this a times c technique. If you want to know more about factoring trinomials, I'm going to pop up a link on your screen right now that you can click to get a little bit of extra help, because I'm going to run through this pretty quickly. If we take a times c, we get 40. We need 2 factors that multiply to 40 that add up to negative 13. That's negative 5 and negative 8. Then what we do is we split this middle term up into 2 pieces, giving us 4t squared minus 5t minus 8t plus 10. This is a good time for me to say, if you have a calculator that you can do this, or some kind of a website, you might want to use that. But this is a pretty nice skill to be able to do by hand anyway. We're going to factor by grouping now. Grouping the first 2 terms together, we can factor a t out. Grouping the last 2 terms together, we can factor a negative 2 out. And you notice that both of these terms have a factor of 4t minus 5 in them. We can factor that 4t minus 5 out, and we're left with a t from the first term and a minus 2 from the second term. So we did all of this work in orange over here just so we could rewrite this numerator as 4t minus 5 times t minus 2. And now you'll notice that our t minus 2 factor in the numerator and the denominator cancel, leaving us just with the limit as t approaches 2 of 4t minus 5. Now if we plug t equals 2 into that, we get negative 4, which was out in front of our limit, times 8 minus 5, which is 3. So we get a final answer of negative 12. And I think I need to go back up to the original problem to see what the units on this thing are going to be. It looks like our position s is measured in feet, and our time t is measured in seconds. So the units on this are going to be feet per second. So what did we just find? Well, given an object that follows this position function right here, after t equals 2 seconds, that object has a velocity of negative 12 feet per second, which means that it's falling at a rate of 12 feet per second. Well, okay, I hope that that problem helps you out. Let me know if you have any questions, and I will see you next time.